Right now, in high-end gyms and professional training facilities all across the world, up to 23% of elite athletes have a federally banned substance sitting right next to their protein powder.
Yeah, right next to the electrolyte mixes and the creatine. It's everywhere.
Exactly. I mean, we're talking about individuals whose entire livelihoods depend on the precise mechanical optimization of their bodies. And they are actively choosing to integrate compounds from the cannabis plant into their daily routines.
Which is just a massive shift. I mean, 10 or 15 years ago, the smell of a locker room was entirely predictable, right?
Oh, totally. You smelled sweat, damp towels, and, that intense minty burn of deep heating muscle rubs. Icy hot everywhere.
Exactly.
Yeah.
But today,
Yeah.
you walk into a recovery room and you are honestly just as likely to see athletes dropping tinctures into their post-workout smoothies. Or they're rubbing these specialized balms on their knees derived from a plant that not too long ago could have ended their entire career.
It is wild to think about.
It really represents a massive cultural and behavioral paradigm shift. And the crazy thing is, it is happening far faster than the scientific community can actually track it.
Right, there's this huge lag.
Huge. The sheer gap between what consumers believe these compounds are doing for their bodies and what the hard physiological data actually proves is staggering.
Yeah.
I mean, we have elite performers treating cannabis like a miracle recovery tool, while the foundational sports science is still struggling to catch up.
And that is exactly why we're doing this deep dive for you today. Because whether you are actively training for a marathon or, spending your evenings lifting heavy in the gym, or even if you are simply trying to cut through the absolute avalanche of health and fitness trends bombarding your social media feeds, you need to understand the biology of what is actually happening here.
You really do, because the cultural footprint is undeniable at this point.
I mean, cannabis is now the second most consumed recreational substance globally, right behind alcohol. In the US alone, we're looking at 52.5 million users.
Which is nearly 19% of the population. That is an incredible demographic spread.
Right. So the question we have to answer for you today is, what does the science actually say? Does integrating cannabis into your fitness routine make you faster? Does it make you stronger?
Or do you actually recover better? Or, on the flip side, are we just witnessing the greatest, most successfully marketed placebo effect in the history of sports wellness?
To answer those questions, we are looking at two highly significant pieces of literature today. First, we are examining a comprehensive 2021 clinical review published in Sports Medicine. And this one rigorously analyzes the historical and modern data on cannabis and athletic performance.
Yeah, it's a fantastic baseline. And second, we are bringing in a really fascinating 2023 survey study from the Journal of Cannabis Research by Pinzone and his colleagues.
And what I love about that second one is that it doesn't look at clinical lab rats.
No, exactly. It looks at how habitually trained, highly active individuals are actually using cannabis in the real world for exercise recovery.
So we are going to separate the biological reality from the locker room mythology. But to even begin making sense of the conflicting data in these studies, we have to establish the foundational biology. I mean, people treat cannabis as a catch-all term in pop culture, but biologically, it is a complex chemical factory.
It really is. The plant itself produces over 100 different genus-specific molecules, which we know as phytocannabinoids.
But out of those 100-plus compounds, we're really only looking at two, right?
Right. The scientific spotlight, and honestly, the regulatory spotlight is almost exclusively trained on two major actors. You have THC, which is delta-9 tetrahydrocannabinol, and you have CBD, or cannabidiol.
And the reason these specific plant molecules have any effect on us at all is because our bodies possess this intricate native biological network called the endocannabinoid system, or the ECS.
Yes. And it's wild because this is a system that wasn't even fully discovered until the early 1990s.
Wait, really? The 90s?
Yeah. We had the receptors in our bodies for millions of years of evolution, but we only found them because scientists were actively trying to figure out how the cannabis plant worked in the human brain.
That is fascinating. So we basically discovered our own biology by studying a plant.
Exactly. So the ECS is essentially a massive, complex lipid signaling network. Our own cells naturally produce endogenous cannabinoids. These are molecules like anandamide, which actually takes its name from the Sanskrit word for bliss.
The bliss molecule. I like that.
Right. And these naturally produced molecules bind to specific receptors to regulate a vast array of physiological functions. We're talking mood, appetite, pain sensation, memory, and systemic inflammation.
And the entire system is built primarily around two specific types of receptors, creatively named CB1 and CB2.
Very creative naming by the scientists there.
Hey, it keeps things simple. But if I remember the physiology correctly, the actual location of these receptors completely dictates the physical response, right?
You hit the nail on the head. That geographic distribution in the body is the key to understanding everything that follows.
So CB1 receptors are heavily concentrated in the central nervous system. So the brain and the spinal cord, though they do show up in peripheral tissues and the cardiovascular system.
Yes. Meanwhile, CB2 receptors are mostly located out in the peripheral tissues, acting as heavy regulators for the immune system and modulating inflammation.
Okay, so knowing where they live, we have to look at how THC and CBD interact with this system. Because they don't do the same thing at all. They use completely different biological mechanics.
They do. Let's start with THC. THC is what we call a partial agonist to both the CB1 and CB2 receptors.
Meaning it acts like a physical key fitting directly into a biological lock.
Precisely. The THC molecule is shaped similarly enough to our native anandamide that it just inserts itself directly into the CB1 receptors in the brain and activates them.
And this direct binding in the central nervous system is what triggers those well-known psychotropic effects, right? The traditional high associated with cannabis.
Exactly. But from an athletic standpoint, the high isn't the main focus. What matters is the secondary cascade. When THC binds to these receptors, it fundamentally alters the autonomic nervous system. Specifically, it upregulates the sympathetic nervous system tone.
Okay, let's clarify that for the listener. The sympathetic nervous system is the body's fight-or-flight architecture.
Yes, it is the gas pedal. When THC upregulates that sympathetic tone, it acts as a physiological stimulant to the cardiovascular system. So the vagus nerve, which normally acts to slow the heart rate down, receives less input.
So the brakes come off.
Right, the brakes come off. The result is a dose-dependent spike in heart rate, which is a condition known clinically as transient sinus tachycardia.
Wow.
You also frequently see acute increases in systolic blood pressure and peripheral vasoconstriction with the blood vessels actively narrow.
Okay, so mechanically, THC is forcing the cardiovascular engine to work harder. The heart is beating faster, and it is pumping blood through narrower pipes.
That's a perfect way to describe it.
Now contrast that with CBD, which has become the absolute undisputed golden child of the modern wellness industry. Every athlete has a CBD sponsor these days.
Oh, absolutely.
Yeah.
But CBD's mechanism of action is entirely different from THC, which is why its effects are so distinct. CBD actually has a very low binding affinity for both CB1 and CB2 receptors.
Meaning it does not fit into the lock the way THC does.
It doesn't. Instead, it acts as what we call a negative allosteric modulator.
Okay, let's visualize that mechanism for the listener. If THC is a copy of a key that goes right into the CB1 keyhole and turns the lock, CBD doesn't go into the keyhole at all.
Right.
Instead, it acts like a piece of gum stuck to the outside of the lock, slightly warping the molecular shape of the keyhole itself.
That is a brilliant analogy. By altering the physical shape of the receptor from the outside, CBD prevents other agonists, so even our own naturally produced endocannabinoids or external THC, from binding as easily or activating the receptor as intensely.
So it's a dampener.
Exactly. Furthermore, CBD interacts with an array of other non-cannabinoid receptors, such as the 5-HT1A serotonin receptors, which are heavily involved in anxiety regulation.
And because it does not bind directly to the CB1 receptor to activate it, CBD is completely non-psychotropic. You don't get high.
You do not. And physiologically, instead of ramping up the sympathetic nervous system like THC does, acute CBD administration tends to mildly stimulate the parasympathetic nervous system.
The rest and digest architecture.
Precisely. So while THC is driving up the heart rate and constricting blood vessels, CBD is actively promoting vasodilation. It is widening those blood vessels and working to lower the resting heart rate and reduce blood pressure.
So they are basically acting on opposing sides of the autonomic nervous system.
They are, and this fundamental mechanical divergence in how they manipulate human physiology has completely dictated the global regulatory landscape in sports.
Which brings us to JEDA, the World Anti-Doping Agency.
Yes. In 2018, JEDA looked at the physiological profiles and completely removed CBD from its prohibited list.
Wow, just totally cleared it.
Totally cleared it. If you are an Olympic weightlifter or a professional tennis player, you can consume pure CBD in competition without triggering a doping violation.
But THC is still firmly on the banned list, right?
Very firmly. THC remains strictly prohibited in competition. It is classified as a threshold substance.
What does that mean practically for an athlete?
In the highly regulated world of anti-doping, it means your urine concentrations cannot exceed 150 nanograms per milliliter. If you cross that threshold during an in-competition test, you are committing an anti-doping rule violation, which typically carries severe suspension penalties.
Okay, so if we look at this purely through the lens of performance, knowing that THC actively hits the physiological gas pedal, it upregulates sympathetic tone, increases heart rate, and boosts systolic blood pressure, it naturally leads to an assumption.
Right, the stimulant assumption.
Exactly. We know that other central nervous system stimulants like caffeine or ephedrine also increase heart rate and sympathetic arousal, and those are definitively proven to improve endurance performance.
We use caffeine constantly in sports science for that exact reason.
Right. So, does the cardiovascular revving caused by THC translate into actual measurable athletic enhancement on the track or in the gym? Does it make you a better athlete?
Well, if you dig into the 2021 clinical review from Sports Medicine, you uncover a scientific landscape that is almost shockingly barren.
Barren? What do you mean?
I mean, if we were discussing caffeine or creatine or beta-alanine, we would have absolute mountains of double-blind, placebo-controlled, peer-reviewed data to sift through. Thousands of papers.
Decades of rigorous testing.
Exactly. But when the authors of this comprehensive review went looking for high-quality data regarding cannabis and athletic performance, they found a conspicuous void.
I was reading through the methodology of that review before we started recording, and it is staggering. At the time of publication, the authors could only identify 10 distinct studies in the entire body of scientific literature that seriously evaluated the acute effects of cannabis on human exercise performance.
Just 10, out of millions of scientific papers globally.
10 studies. But honestly, the real issue isn't just the low number of studies, it is when those studies were actually conducted.
Yes, the timeline is the first massive methodological red flag. The vast majority of the experimental literature where researchers actually administered cannabis to human subjects prior to a bout of exercise was published 35 to 45 years ago.
So we are relying on data generated in the 1970s and 1980s.
We are, which means the rules governing elite athletes today and the foundational knowledge base that coaches and trainers are operating from is built on an era of cannabis that doesn't even biologically exist anymore.
Explain that. What do you mean it doesn't exist?
It is a completely different botanical reality today. Through decades of selective breeding, optimized hydroponic cultivation, and, advanced extraction techniques, the chemical profile of modern cannabis is unrecognizable compared to the plant material used in a 1975 laboratory setting.
It's way stronger now.
Exponentially stronger. The typical THC concentration in a modern recreational or medicinal product is easily 6 to 10 times higher than the doses administered in those historical studies. The terpene profiles are different, the cannabinoid ratios are different, everything has changed.
But the dosage and the plant chemistry aren't even the most egregious flaws in this historical research, are they? The fatal flaw lies in the test subjects themselves.
Oh, absolutely. This is the part that drives sports scientists crazy.
Right, because if you want to know how a drug affects a high-performance athlete, common sense says you test it on a high-performance athlete. But that is not what these researchers did.
Not at all. Fully half of the experimental studies examining cannabis and exercise performance in this historical cohort were performed on diseased populations.
Diseased populations? You mean sick people?
Yes. We are talking about patients suffering from severe advanced pathologies. Specifically, individuals with significant coronary artery disease or patients grappling with advanced chronic obstructive pulmonary disease, COPD.
I really want to focus on one specific, heavily cited study from 1974 by Aronow and Cassidy because it perfectly illustrates how warped this data is.
Yes, the angina study.
Right. This study is constantly pointed to in older literature as definitive proof that cannabis ruins exercise capacity. Let's look under the hood of that study. They took 10 patients who had significant coronary artery disease, and we aren't talking about mild plaque buildup here.
No. These patients had greater than 75% narrowing of their major coronary arteries. Their myocardial blood flow was already severely compromised before the experiment even began.
And the researchers had these patients smoke either a cannabis cigarette or a placebo cigarette. Then they put them on a stationary cycle ergometer and instructed them to pedal until the onset of angina.
Which is just a recipe for disaster.
Let's define angina for the listener. Angina is severe crushing chest pain caused by ischemia, basically a lack of oxygenated blood reaching the heart muscle. If we map the mechanisms here, it is a recipe for instant cardiovascular failure.
It really is.
The patient smokes cannabis. The combustion of the plant material introduces carbon monoxide into the lungs. Hemoglobin in the blood has an affinity for carbon monoxide that is roughly 200 times higher than its affinity for oxygen. So immediately, the oxygen-carrying capacity of the blood plummets.
Right, you're choking the blood of oxygen.
Exactly. And simultaneously, the THC enters the bloodstream, hits the CB1 receptors, upregulates the sympathetic nervous system, and causes the heart rate to spike.
It's the ultimate physiological bottleneck. The heart muscle is suddenly beating much faster, demanding significantly more oxygen to sustain the workload of pedaling. But because the coronary arteries are 75% blocked, and the blood itself is saturated with carbon monoxide instead of oxygen, the supply cannot possibly meet the demand.
So ischemia sets in immediately.
Instantly, the chest pain triggers, and the patient has to stop exercising.
And the results of the study showed exactly that. After smoking cannabis, the patient's time to exhaustion decreased by 48%. Their performance plummeted compared to the placebo. But here is the absolute kicker. When you look at the actual physical output required to induce that failure, the maximum power output these patients could sustain during the test was a mere 25 watts.
Yeah, that number is mind-blowing. The authors of the Sports Medicine Review single out that 25-watt metric to highlight the absurdity of extrapolating this data.
Just to put 25 watts into perspective for the listener.
Right, 25 watts is essentially the power required to slowly turn the pedals on a bike with zero mechanical resistance. A modern professional male cyclist routinely sustains an output of around 500 watts for a 2-minute duration, and they do it amidst hours of grueling riding on consecutive days.
So to take a 25-watt failure in a patient with 75% arterial blockage and use that data point to confidently predict the performance effects of cannabis on a healthy 500-watt endurance athlete is it's a massive failure of scientific logic.
It violates common sense.
Right. If I tried to tell you exactly how the suspension and transmission of a Formula One car handles a tight corner at high speeds, and my only evidence was a test drive I did in a broken golf cart with a flat tire, you would laugh me out of the room.
I absolutely would.
Yet sports science accepted these flawed baselines for decades. Why? Why didn't researchers just bring healthy athletes into the lab and test them?
The answer is entirely bureaucratic and legal. It wasn't that scientists didn't want to test athletes. The regulatory hurdles created by the Schedule I status of cannabis made high-rigor athletic testing almost impossible.
Oh, because it's federally illegal.
Exactly. To get approval from an institutional review board to administer a federally illegal psychoactive substance to healthy athletes, and then intentionally push their cardiovascular systems to absolute maximum failure in a laboratory setting, it was a liability nightmare.
I can imagine the university lawyers having a heart attack over that.
Funding agencies wouldn't even touch it. So researchers, policymakers, and eventually sports organizations leaned on the only peer-reviewed data they had available, which were these clinical stress tests designed specifically to trigger symptoms of underlying cardiovascular disease, not to measure human athletic potential.
So we essentially have to throw out the diseased population studies entirely. They tell us nothing about athletic performance.
Nothing at all.
When we clear away that noise, we are left with a tiny handful of historical studies that actually tested healthy, active individuals. But interpreting even those studies requires us to look incredibly closely at the specific metrics the researchers use to define performance.
And the cardiovascular system remains at the center of the confusion here. In healthy individuals, the primary acute physical response to cannabis is that transient sinus tachycardia we mentioned earlier.
The artificially fast heartbeat.
Right. The heart beats faster, independent of physical exertion. And this specific pharmacological effect severely compromised a landmark 1975 study by Stedward and Singh.
I was looking at the Stedward and Singh study, and the abstract concludes that cannabis significantly reduced physical work capacity. It literally labeled the drug as an ergolytic substance, an active performance killer.
It did. But when you examine the methodology, they didn't measure performance by having the subjects run a timed mile or pedal until they collapsed. They used a specific protocol called the PWC 170.
The physical work capacity at 170 beats per minute.
Exactly. This is a sub-maximal exercise test. Instead of pushing the participant to total exhaustion, the researchers incrementally increased the resistance on a stationary bike. And they measure the exact power output the subject is producing at the precise moment their heart rate reaches 170 beats per minute.
But why are they measuring performance based on an arbitrary 170-beat heart rate proxy instead of actual physical output? That seems like a strange way to measure endurance.
Well, you have to remember, this was the 1970s. And even today, in certain field tests, measuring true maximal oxygen uptake VO2 max required expensive, cumbersome metabolic carts to analyze expired gases.
Yeah.
It wasn't easy to do. However, in a normal, sober human body, there is a highly reliable linear relationship between heart rate and oxygen consumption during progressive exercise. As your muscles demand more oxygen to create ATP for energy, your heart rate increases proportionately to deliver it.
So they move together in lockstep.
Yes. Because of this locked linear relationship, sports scientists could safely use heart rate as a convenient, non-invasive proxy to estimate overall aerobic fitness and work capacity.
Okay, the operative word there being sober. This is where the methodology completely falls apart. We just established that THC acts directly on the autonomic nervous system to artificially inflate the heart rate.
Exactly. The drug itself causes tachycardia independent of any oxygen demand from the skeletal muscles.
So THC chemically breaks the linear relationship between heart rate and physical exertion.
Precisely. So when the healthy subjects in the Stedward and Singh study smoked a moderate dose of cannabis, about 18.2 milligrams of THC, their resting heart rates were already elevated before they even started pedaling the bike.
So they were already closer to the 170 ceiling.
Yes. As the resistance on the bike increased, their heart rates spiked aggressively early in the test. They hit that 170 beats per minute ceiling at a significantly lower power output than they did when they were on the placebo.
Wow. So the researchers looked at the low power output at 170 BPM and recorded it as a massive drop in physical work capacity.
They did.
But their leg muscles weren't actually failing. Their lungs weren't actually giving out. They weren't experiencing systemic fatigue. The metric of measurement itself had been pharmacologically hijacked.
That's exactly it. The tool they were using to measure performance was broken by the substance they were trying to test.
The logic here is incredibly inconsistent when you compare it to other sports supplements. I mean, caffeine actively increases your submaximal heart rate, ephedrine actively increases your submaximal heart rate.
And we know both of those improves performance.
Exactly. Definitively known to improve endurance. So confusing a chemically induced fast heartbeat with a drop in actual athletic capacity is like looking at the dashboard of a car, seeing high RPMs, and assuming the engine is broken and losing power when the reality is the driver just shifted into a lower gear.
That's a great way to think about it. The RPMs don't tell the whole story of the vehicle's speed.
No, they don't.
The authors of the 2021 review emphasize exactly that point. You absolutely cannot conflate the tachycardic effects of cannabis with an ergolytic, performance-destroying effect based on submaximal proxy tests.
So to find out what actually happens when you bypass the heart rate proxies and push a healthy person to their true physical metabolic limit under the influence of THC, we have to look at another study.
Yes, we look at one of the very few studies to ever do it, the 1986 Renaud and Cormier study.
1986. It is genuinely wild to me that we are still relying on a sample size from the Reagan administration to understand elite physiology today.
It's frustrating, but it's what we have. But the Renaud and Cormier methodology was fundamentally different.
What happened when they pushed healthy subjects to the absolute maximum?
They recruited 12 healthy, active subjects and administered 7 milligrams of dried cannabis per kilogram of body weight. The plant material had a standardized THC concentration of about 1.7%.
Okay.
After consumption, they put the subjects on a cycle ergometer and used a progressively challenging staged protocol that forced them to pedal until total involuntary leg failure. They didn't stop at a target heart rate. They stopped when the muscles simply could not contract anymore.
Real failure. And what did the metabolic data show?
During the submaximal stages of the test, they observed the exact same phenomenon as Stedward and Singh. The cannabis group had significantly higher heart rates for the given workload.
The tachycardia.
Right. However, as the exercise intensity ramped up toward maximum effort, the physiological gap between the cannabis group and the placebo group rapidly began to close.
Because the intense sympathetic drive of maximal exercise essentially overrides the baseline sympathetic upregulation caused by the THC.
Exactly. When you are at maximum exertion, your body is flooding the system with catecholamines, epinephrine, and norepinephrine, regardless of what drug you took beforehand.
Your body's own natural adrenaline takes over.
Yes. And at that point of maximal effort, the physiological responses were virtually identical. The subject's VO2 max, the maximum volume of oxygen they could utilize, was completely unchanged. Their volume of exhaled carbon dioxide was identical. Their peak pulmonary ventilation rates were the same.
Wow.
Every single core metabolic marker of maximal aerobic capacity was completely unaffected by the cannabis.
So the assumption that THC inherently ruins your aerobic engine is biologically false.
Based on this data, yes, it is false.
But did it affect their endurance time at all? Did they quit sooner?
The only statistically significant difference recorded in the entire maximal test was a tiny decrease in the total time to exhaustion for the cannabis group. They reached volitional failure slightly earlier than they did on the placebo.
How much earlier are we talking? Are we talking minutes, hours?
On average, the subjects lasted 15.1 minutes on cannabis, compared to 16.1 minutes on the placebo.
1 minute.
It was exactly 1 minute of difference on a progressively staged test. In terms of sheer power output, that missing minute equates to a difference of roughly 16 watts.
That's nothing.
The clinical review authors critically note that the practical validity and real-world significance of a 16-watt difference on a staged laboratory test from 1986 is highly debatable.
Okay, so if we synthesize this historical data for the listener, someone who is, lacing up their shoes right now for a 10K run or prepping for a grueling metabolic conditioning circuit, the physiological reality is incredibly clear.
Very clear.
There is absolutely zero objective data supporting the idea that THC acts as an ergogenic aid during active exertion. It does not increase your oxygen uptake, it does not increase your maximal power output, and it certainly does not make you faster.
No, it doesn't. Furthermore, while it might not completely ruin your VO2 max, the cardiovascular tax is a very real, very negative factor. That drug-induced tachycardia leads to a significantly higher rate pressure product.
Okay, let's break down the rate pressure product mechanically because this is crucial for endurance athletes to understand.
Absolutely. The rate pressure product is simply your heart rate multiplied by your systolic blood pressure. It is the most accurate, non-invasive metric we have to measure myocardial oxygen demand, basically. How much oxygen the actual muscle of the heart requires to keep pumping.
Right.
Because THC drives up both the heart rate and the blood pressure during submaximal exercise, your heart is forced to consume significantly more oxygen and energy just to sustain the exact same physical output to the pedals or the pavement.
You are demanding more fuel for the engine without getting any extra horsepower to the wheels.
That's a perfect analogy. Over the course of a 2-hour endurance event, that internal cardiovascular inefficiency represents a major metabolic leak. It is a hindrance, not a help.
So, evaluating cannabis as a pre-workout supplement yields a pretty dismal physiological report card. It strains the heart, it doesn't boost power, and the historical data, flawed as it is, points to a slight decrease in time to exhaustion.
Right.
But this conclusion exposes a massive paradox. If the cardiovascular tax is this high, and elite athletes are tracking their biological metrics obsessively with wearables and chest straps, they must know it is not making them faster on the track. The data doesn't lie to them.
They absolutely know.
So why is usage skyrocketing to 23%? They must be integrating it at a completely different phase of their training cycle.
Yes.
The cultural explosion we are witnessing isn't about the pre-workout phase at all. It is entirely about the post-workout phase. It is about recovery.
That is the exact pivot point where the science has to shift its focus, and it brings us directly to our second major source. The 2023 survey study published in the Journal of Cannabis Research by Pinzone and his colleagues.
This is where things get really interesting.
It does, because this study completely abandons the laboratory cycle ergometer and attempts to capture the behavioral reality of modern fitness culture. They wanted to know exactly what highly trained, habituated individuals are doing with cannabis in their actual daily routines.
And the demographics of this survey are vital to understand because these aren't casual individuals who go for a light walk once a week. Tell us about the cohort Pinzone studied.
The researchers successfully surveyed 111 individuals who reported both habitual cannabis use and a regular, dedicated training regimen. And the athletic profile of this group is incredibly robust.
These are serious athletes.
Very serious. 85% of the participants reported regular participation in high-intensity aerobic training, so running, cycling, swimming. And exactly 85% also reported regular participation in resistance training and weightlifting.
So they're lifting and doing cardio.
In fact, a full 72% of the cohort routinely engages in both modalities. These are dedicated, physically taxed individuals who understand the demands of systemic recovery. The researchers asked them a series of direct questions about their subjective experience with cannabis and exercise.
And what were the subjective results? Do they believe it actually works?
The results represent an overwhelming, almost unanimous consensus.
Really?
Yes. 93% of the users who consumed CBD explicitly stated that they felt it assisted them with their exercise recovery. And 87% of the users who consumed THC felt that it actively aided in their recovery process.
Over 90% positive feedback for CBD. In any behavioral survey, getting 90% of humans to agree on the efficacy of anything is nearly impossible.
It's unheard of. But what is perhaps even more telling is the negative response rate. Out of the 111 highly active individuals surveyed, not a single person answered no when asked if cannabis aided their recovery.
0 no answers.
0. A small fraction selected unsure, but absolutely 0 participants definitively felt it was ineffective.
That's crazy. So if they aren't using it to run faster or lift heavier, what specific physiological relief are they seeking? What is the perceived benefit that keeps them coming back to these compounds?
Well, the researchers asked the participants to rank their primary motivations for use, isolating CBD and THC. For the CBD users, the dominant motivations were to assist with sleep onset and maintenance and to promote general systemic relaxation.
Okay, so calming down the nervous system.
Exactly. For the THC users, the primary motive was to relax, followed closely by achieving a subjective pleasant feeling, assisting with sleep, and alleviating localized pain.
So they are actively targeting central nervous system downregulation and pain management.
They are. The study also revealed some fascinating demographic and behavioral splits regarding training intensity. For instance, the male participants who exclusively utilized CBD reported engaging in significantly higher intensities of both aerobic and resistance exercise compared to the males who exclusively utilized THC.
Oh, that's interesting. So that suggests the athletes pushing their muscular and metabolic systems closest to the absolute limit, the ones generating the most severe micro-trauma in their muscle fibers, are gravitationally pulled toward the non-intoxicating anti-inflammatory properties of CBD.
Right, rather than the psychoactive relief of THC.
If we zoom out and look at the broader landscape of sports science, we see a massive divergence here between the lack of objective performance enhancement and the overwhelming subjective belief in enhanced recovery.
It's a huge gap. But this behavior is actually entirely consistent with how elite athletes treat other recovery modalities. Athletes are utilizing cannabis through the exact same theoretical framework they use when they step into a cryotherapy chamber or a contrast water bath.
Let's map that comparison because it perfectly illustrates the intention behind the usage.
The Pinzone survey explicitly draws parallels to these unproven or heavily debated ancillary modalities. Take whole-body cryotherapy, for example. The objective data showing that standing in a freezing chamber immediately improves your sprint speed the next day is highly conflicting.
Very conflicting. Some studies say it does nothing for performance.
Right. But athletes use it because the extreme cold induces intense peripheral vasoconstriction, which theoretically helps flush metabolic byproducts out of the extremities. And it has been shown in some studies to temporarily decrease circulating pro-inflammatory cytokines like interleukin-2.
So they feel better subjectively.
Exactly. Similarly, contrast water therapy alternating between hot and cold tubs creates a vascular pumping action that has been shown to accelerate the clearance of creatine kinase, a primary biomarker of muscle damage, within 24 to 48 hours post-exercise.
So the athletes aren't looking for a magic bullet that builds instantaneous muscle mass. They are aggressively targeting the secondary consequences of training.
Yes.
They want to mitigate DOMS delayed onset muscle soreness, and they want to damp down the acute nervous system fatigue so they can wake up the next morning and subject their bodies to high-intensity stress all over again. They are treating cannabis as a systemic biological dampener.
Precisely. They view the cannabinoids as pharmacological tools to manage inflammation and neurological arousal.
Which brings us to the most critical question of this entire deep dive. For you, the listener, who is considering adding these compounds to your recovery protocol based on the fact that 93% of surveyed athletes swear by them, is there a hard pharmacological mechanism driving this relief, or are we just looking at the ultimate, highly lucrative placebo effect?
It's the million-dollar question.
Right. Because you execute a brutal set of heavy squats, your central nervous system is completely fried, you take a CBD gummy, you feel a wave of relaxation, you sleep deeply, and you wake up convinced the cannabinoid physically repaired your torn muscle fibers.
When the reality might just be that you've finally got a full 8 hours of uninterrupted sleep.
Exactly. And deep sleep is when the body naturally releases human growth hormone to repair tissue. The sleep did the repairing, not necessarily the gummy.
So to determine whether this is a biological reality or a beautifully packaged placebo, we have to pull the specific subjective claims from the Pinzone survey: better sleep, reduced muscle pain, and neurological recovery, and subject them to the rigorous clinical microscopy of the 2021 review.
And we must begin with the compound that currently dominates the athletic wellness market, CBD.
Yes, CBD is ubiquitous. Everyone from professional ultramarathoners to recreational weekend warriors is consuming it for sleep regulation and joint pain. Let's look at the hard clinical science regarding sleep architecture.
Sleep is the ultimate recovery variable.
It really is. And elite athletes are notorious for suffering from suboptimal sleep architecture. They face chronic circadian disruption from cross-country travel, the physiological hyperarousal of competing late at night under stadium lights, and the intense psychological anxiety of performance expectations.
When your sympathetic nervous system is still flooded with residual catecholamines from a game, and your brain is obsessively replaying a missed play, slipping into deep, restorative, slow-wave sleep is incredibly difficult.
Does CBD effectively counteract that hyperarousal? Well, the clinical data reveals that CBD's efficacy as a sleep aid is profoundly context-dependent.
Context-dependent how?
If you look at diseased or highly distressed clinical populations, for example, patients suffering from Parkinson's disease or individuals diagnosed with severe post-traumatic stress disorder, CBD administration has demonstrated genuine, quantifiable promise in improving both sleep quality and total sleep duration.
Okay.
It actively reduces complex, disruptive sleep-related behaviors in these highly sensitized nervous systems.
But the architecture of a traumatized or diseased brain is fundamentally different from the architecture of a healthy, physically exhausted athlete. What happens when you give CBD to a healthy individual?
That is precisely where the broad wellness claims falter. The 2021 clinical review highlights a rigorous study conducted on completely healthy subjects. The researchers administered a massive oral dose of 300 milligrams of CBD.
300 milligrams.
Yes, 300 milligrams. And they didn't just ask the subjects how they slept, they monitored them utilizing objective polysomnography. This means they were tracking the subject's brainwave activity via EEG, their blood oxygen levels, heart rate, and respiratory patterns throughout the entire night to analyze the specific stages of REM and non-REM sleep.
Let me stop you right there, because the dosage is crucial for the listener to understand. A standard over-the-counter CBD gummy or oil dropper that an athlete might buy at a health food store typically contains anywhere from 10 to 25 milligrams of CBD.
Right.
This study hit the subjects with 300 milligrams. That is a massive pharmacological load. So what did the objective polysomnography show with that huge dose?
The objective results showed absolutely zero significant effects on the subject's sleep quality or the underlying sleep architecture.
Zero.
None. It did not alter the sleep-wake cycle, it did not increase the duration of slow-wave sleep, and it did not change the onset time to REM sleep.
If we break down the why behind that failure, it actually makes perfect physiological sense. CBD is not a central nervous system depressant in the way a prescription medication like Ambien or a benzodiazepine is.
No, it's not a sedative.
Right. It doesn't forcefully bind to GABA receptors to shut the brain down. Instead, its sleep benefits in clinical populations seem to stem from its anxiolytic properties, its ability to damp down excessive cortisol and pathological anxiety.
Exactly.
But if you have a healthy 25-year-old athlete whose sympathetic nervous system naturally returns to a calm baseline after exercise, their cortisol levels aren't pathologically elevated at bedtime. Damping down an alarm system that isn't actually ringing yields zero net change to the sleep architecture.
That is an incredibly accurate assessment of the pharmacological limits of CBD. It is a modulator, not a sedative.
Okay, so if we discard the idea that CBD acts as a magic sleeping pill for healthy individuals, we have to look at the other major claim: pain management and structural muscle repair. This is the absolute bread and butter of the sports supplement industry.
It is.
You lift heavy weights, you induce mechanical tension that causes micro tears in the sarcomeres of the muscle fibers. The immune system triggers a localized inflammatory response to clean up the damage, and the resulting swelling and chemical signaling cause the pain we know as DOMS. Does CBD actively intercept that inflammatory cascade and fix the muscle?
Let's examine the data on pain management first, because it reveals a fascinating disconnect. The review analyzes a study focused on professional male rugby players.
Rugby is intense.
It is a sport synonymous with massive biomechanical impact, blunt force trauma, and chronic systemic pain. The survey found that 26% of the professional players actively use or have experimented with CBD products. And of those users, an overwhelming 80% cited pain management as their primary motivation for consumption.
Given the sheer physics of a rugby tackle, relying on systemic anti-inflammatories is basically a job requirement.
But here's the critical, almost contradictory data point from that study. Of the 80% who were explicitly taking CBD to manage their physical pain, only 14% actually reported experiencing a beneficial, perceptible pain-relieving effect.
Have to pause on that math.
It's pretty glaring, right?
Yeah. If 80% of the athletes are purchasing and consuming a supplement specifically to alleviate pain, but only 14% of them are actually getting relief, why on earth do the other 66% continue to take it?
The massive failure rate and perceived efficacy comes down to a fundamental pharmacological hurdle known as the dosage problem. The efficacy of CBD as an active anti-inflammatory agent and an analgesic is entirely dose-dependent.
Meaning you need enough of it to make a difference.
Exactly. When we look at clinical trials evaluating CBD for severe chronic pathologies like gastrointestinal inflammation or autoimmune conditions, low oral doses of CBD, typically around 10 to 20 milligrams, frequently show absolutely no statistically significant pain relief when compared to a placebo.
So the normal store-bought dose fails in the clinic.
Completely. To achieve a measurable systemic reduction in clinical inflammation, researchers often have to push the oral administration up to massive levels, routinely hitting 300 to 500 milligrams per day.
Why is the required oral dose so astronomically high?
It is due to a biological mechanism called first-pass metabolism. When you swallow a CBD gummy or oil, it doesn't just instantly enter your bloodstream. It has to pass through the gastrointestinal tract and then be aggressively processed by the liver before it ever reaches systemic circulation.
The liver acts like a filter.
A very aggressive filter. The liver enzymes break down and clear out the vast majority of the CBD immediately. The oral bioavailability of CBD in humans is estimated to be as low as 6%.
6%.
Yes, this means if you eat a standard 20 milligram gummy, your liver destroys so much of it that only about 1.2 milligrams actually makes it into your bloodstream to interact with your endocannabinoid system.
If the oral bioavailability is that staggeringly low, then the entire over-the-counter wellness industry is basically selling expensive hemp-flavored placebo candy to people who don't understand pharmacokinetics.
That's a harsh way to put it, but pharmacologically you're not wrong.
I mean, buying a cheap 10 milligram CBD gummy to cure the systemic inflammation caused by a brutal deadlift session is essentially like trying to put out a roaring campfire with a plastic water gun. You have the right underlying theory water puts out fire, but you have absolutely the wrong mechanical firepower to influence the outcome.
The pharmacokinetic math simply does not support the commercial claims. And furthermore, at the massive 500 milligram doses required to actually bypass liver clearance and achieve systemic anti-inflammatory effects, patients frequently begin experiencing adverse clinical side effects.
Like what?
Things like severe gastrointestinal distress and central nervous system lethargy.
What happens when researchers bypass the subjective surveys entirely and just measure the cold, hard objective markers of muscle damage? Do the blood panels show CBD repairing the microtears faster?
The objective data on skeletal muscle function is incredibly murky and highly contradictory.
Okay, let's hear the studies.
One rigorously controlled study took a group of untrained males, put them through a severe, muscle-damaging, eccentric exercise protocol, and then administered 150 milligrams of CBD daily for 3 consecutive days. They tracked their perceived soreness and objectively measured their force production.
And the result?
The CBD administration yielded absolutely no beneficial effects on the recovery of muscle function or the attenuation of localized soreness compared to the placebo.
Total failure to enhance recovery.
Yes, in that specific model. However, to demonstrate how experimental and unsettled this frontier is, a separate preliminary study utilized a different methodology. They took trained individuals, subjected them to an intense resistance workout, and administered CBD. They tracked the athlete's 1 repetition maximum strength 72 hours post-exercise, and they drew blood to monitor specific biomarkers of muscle damage, primarily focusing on myoglobin.
Let's explain myoglobin quickly for context. Myoglobin is an oxygen-binding protein that normally lives safely inside the muscle fibers. When you train hard and severely damage the muscle cell membrane, the cell leaks. The myoglobin spills out of the muscle and enters the bloodstream. So high levels of myoglobin in a blood test equal severe structural muscle damage.
Exactly. In this specific study, the cohort receiving CBD actually maintained, and in some cases slightly increased, their 1 rep max strength compared to their baseline testing, while a placebo group saw a drop in force production.
Oh, wow.
Crucially, the CBD group also demonstrated attenuated blood markers for muscle damage, specifically showing reduced circulating levels of myoglobin 72 hours post-workout.
So we have one highly controlled study showing 150 milligrams does absolutely nothing for muscle force, and another study showing it potentially protects strength and maintains the structural integrity of the cell membrane.
Welcome to cannabinoid research. The clinical evidence regarding CBD's ability to repair skeletal muscle is in its absolute infancy. The conflicting results are the product of vastly different methodologies.
Different variables everywhere.
Everywhere. The dosages vary wildly. The routes of administration, oral, sublingual, topical, create massive discrepancies in bioavailability, and the specific mechanical stress of the exercise protocols are not standardized. We simply do not possess enough high-rigor, reproducible data to confidently state that CBD accelerates the repair of skeletal muscle fibers.
If the evidence for sleep architecture is negligible for healthy people, and the evidence for muscle repair is hopelessly contradictory, it begs the question of why we are even discussing CBD.
It does, but there is one specific area of sports recovery where the clinical potential of CBD is turning heads in a major way. And it actually has nothing to do with repairing your biceps or your quads.
It has to do with protecting the single most important organ in the body, the brain.
Yes. This is perhaps the most critical, consequential, and scientifically promising avenue of all cannabinoid research in sports. The application of CBD as a neuroprotectant in the context of mild traumatic brain injury, or MTBI.
We are talking about concussions. This is a massive existential crisis across almost all collision and combat sports right now. Football, rugby, mixed martial arts, boxing, hockey, and even the repetitive micro-traumas experienced in soccer headers.
It's epidemic.
The long-term physiological consequences of concussions are terrifying. We're seeing epidemics of chronic traumatic encephalopathy, CTE, severe chronic depression, crippling anxiety, and aggressive behavioral changes in retired athletes.
The biomechanics of a concussion trigger a devastating biological cascade. When the skull sustains a high-impact deceleration or a severe rotational force, the brain physically shifts and impacts the interior of the cranium.
The brain literally bruises itself against the skull.
Yes, and this mechanical trauma causes a shearing of the axons, the long, thread-like parts of the nerve cells that conduct electrical impulses. This immediate structural damage initiates a massive neuroinflammatory response.
Which is where the secondary damage comes in.
Right. The brain's immune cells, called microglia, become hyperactivated, releasing a storm of pro-inflammatory cytokines that can cause secondary long-lasting damage to the neural tissue. This is the exact physiological environment where CBD is demonstrating profound therapeutic potential.
Now, obviously, for profound ethical and logistical reasons, we cannot intentionally concuss a group of human athletes in a lab and feed half of them CBD to see what happens. So where is this neuroprotective data coming from?
We rely heavily on robust murine models studies conducted on mice. A recent, highly significant study intentionally induced mild traumatic brain injuries in a cohort of mice, replicating the biomechanical forces of a sports concussion.
Okay.
Following the trauma, the researchers administered chronic, daily doses of CBD. If you utilize standard allometric scaling to convert the murine dosage to a human equivalent, it equates to roughly 51 milligrams of CBD per day.
And then they just watched how the mice recovered.
Exactly. The researchers closely monitored the behavioral and neurological recovery of the subjects.
What happens to the behavior of a concussed brain when you introduce CBD?
The results were highly compelling. The researchers observed that the chronic CBD administration significantly reduced the aggressive, anxious, and depressive behaviors that the mice typically exhibited following a traumatic brain injury.
That is incredible. But how exactly is a plant lipid preventing the brain from descending into a depressive, anxious state after physical trauma? What is the actual molecular mechanism driving that protection?
While the complete neural pathways are still being actively mapped, neuroscientists point to a multi-pronged mechanism of action. First, CBD's potent systemic anti-inflammatory properties likely act to cool down the hyperactive microglial cells, mitigating that secondary cytokine storm and reducing overall neuroinflammation inside the skull.
So it puts out the inflammatory fire in the brain?
Yes. Second, CBD interacts heavily with the endocannabinoid system's regulatory enzymes. Specifically, it inhibits the enzymatic hydrolysis, the breakdown of anandamide.
Let's explain enzymatic hydrolysis, because it's basically the brain's biochemical cleanup crew. Once your brain utilizes a bliss molecule like anandamide to regulate mood or pain, enzymes rush in to break the molecule down and sweep it away.
Exactly. By inhibiting those specific enzymes, CBD essentially blocks the cleanup crew. It It allows the natural anandamide to remain in the synaptic clefts longer, maintaining higher levels of our natural endocannabinoids, which help stabilize mood and limit pain signaling.
That's fascinating. And what's a third mechanism?
Third, CBD appears to actively decrease the reuptake of adenosine. Adenosine is a neuromodulator that naturally builds up in the brain during waking hours, eventually creating sleep pressure. By keeping adenosine circulating in the synapses, CBD leverages its powerful neuroprotective and central nervous system calming effects.
Wow.
For an athlete competing in a combat or collision sport, the prospect of a prophylactic or post-injury neuroprotectant that operates on these three distinct pathways is the absolute holy grail of sports medicine.
The potential is undeniable. But, and there is always a massive but, when we delve into the pharmacokinetics of supplements, this neuroprotection does not come for free.
No, it doesn't.
If you are an athlete listening to this deep dive, or a parent of an athlete, and you're thinking, this is fantastic, I am going to start taking 100 milligrams of CBD every single day to proactively armor my brain against microtraumas, there are some severe hidden biological dangers you must understand. Let's talk about the liver, because this is the massive blind spot of the entire wellness industry.
The metabolic risks associated with high-dose CBD consumption are incredibly real and almost entirely ignored by commercial marketing. When you ingest a high dose of CBD to achieve those neuroprotective or anti-inflammatory effects, the compound doesn't just bypass your organs and teleport to your brain.
Right, as we said, it has to go through the filter.
It must be heavily metabolized in the liver.
Yeah.
Specifically, CBD is oxidized and broken down by the cytochrome P450 enzyme system, heavily relying on two specific enzymes known as CYP3A4 and CYP219.
Why does a fitness-minded listener need to care about the specific names of liver enzymes?
Because the cytochrome P450 system is the central chemical processing plant of the human body. And the CYP3A4 enzyme is the exact same enzymatic pathway responsible for metabolizing approximately 60% of all clinically prescribed pharmaceutical medications currently on the market.
Oh, wow. So if you flood the liver with massive doses of CBD, you are creating a biochemical traffic jam.
Competitive inhibition is the clinical term. The high dose of CBD monopolizes the CYP3A4 enzymes. The liver is so busy processing the cannabinoid that it doesn't have enough enzymes left over to process anything else.
So the other drugs just sit there.
Yes. Therefore, if you are concurrently taking another medication, your liver cannot break it down efficiently. The medication builds up in your bloodstream, extending its half-life and potentially reaching highly toxic concentrations. This is a severe drug-drug interaction.
Wait, isn't this the exact same biological mechanism that prompts your doctor or pharmacist to put a warning label on certain statins or blood pressure medications, telling you never to consume them with grapefruit juice?
It is the exact same mechanism.
Yeah.
Grapefruit juice contains compounds that block the exact same CYP3A4 liver enzymes, and clinical trials have documented severe adverse events utilizing high-dose CBD.
Like what kind of events?
For example, in trials evaluating CBD for patients suffering from severe epilepsy, many subjects were concurrently taking a standard anti-epileptic medication called clobazam. When the researchers introduced high doses of CBD, the CBD monopolized the liver enzymes.
And the clobazam just built up?
Exactly.
Yeah.
As a result, the blood concentrations of clobazam skyrocketed, causing the adverse side effects of the epilepsy medication, severe sedation, lethargy, and respiratory depression to aggressively amplify because the body physically could not clear the drug.
That is genuinely scary. So if a professional athlete is taking prescription NSAIDs for chronic joint pain, or utilizing antidepressants, or managing a condition with heart medication, and they simultaneously start downing 200 milligram doses of CBD oil for recovery, they are playing an incredibly dangerous, unregulated game with their liver metabolism.
They are. And the drug interaction in the liver isn't the only dangerous game they are playing. If you are an athlete who is subject to strict WADA anti-doping protocols, or honestly, if you are just a normal civilian whose employer conducts random workplace drug screens, the current commercial CBD supplement market is an absolute minefield.
The phrase Russian roulette is frequently used by anti-doping agencies to describe the commercial CBD market, and it is entirely appropriate.
Absolutely appropriate. Because CBD itself is federally legal in many jurisdictions, the commercial market has absolutely exploded with tinctures, balms, vapes, and gummies. But this market exists in a regulatory gray area. It is largely unregulated by the FDA in terms of strict pharmaceutical purity.
And the 2021 clinical review highlighted a terrifying laboratory analysis of the commercial marketplace to prove this, right?
Yes, they did. Researchers randomly selected 25 different commercial CBD products available to consumers and subjected them to rigorous gas chromatography testing in a lab to analyze their actual chemical content.
Well, what did they find?
Out of the 25 products tested, only 3 actually contain the amount of CBD claimed on the label within an acceptable 20% margin of error.
3 out of 25. That means 88% of the time, the consumer has absolutely no idea what pharmacological dose they're actually ingesting. The label is essentially a work of fiction.
And the inaccuracy of the dosage isn't even the greatest threat to an athlete. The critical danger lies in contamination. Many of these commercial products are aggressively marketed as full-spectrum extracts.
Which people think is a good thing.
Right. Proponents of full-spectrum products argue for the entourage effect, the botanical theory that CBD is therapeutically more effective when it is consumed alongside the hundreds of other trace cannabinoids, terpenes, and flavonoids naturally found in the raw plant material.
And from a purely therapeutic standpoint, there may be a valid biochemical truth to the entourage effect.
There might be. But for a drug-tested athlete, consuming a full-spectrum product is an unmitigated disaster. Those trace cannabinoids invariably include THC.
Oh, man.
You might purchase a product explicitly marketed and labeled as THC-free, but due to poor extraction methods, cross-contamination in the manufacturing facility, or deliberate mislabeling, the product actually contains enough trace THC to accumulate in your system and trigger a catastrophic anti-doping rule violation.
But let's build a hypothetical scenario to test the limits of this danger. Let's say I'm an elite athlete, I'm incredibly careful, I don't trust the commercial supplement market, so I never use CBD oils or full-spectrum gummies. However, a month ago, during the off-season when I wasn't subject to testing, I smoked a small amount of cannabis recreationally. I am totally clean now. I haven't consumed a single cannabinoid in 4 weeks. I go to training camp, I endure a brutal 2-hour metabolic conditioning circuit under the hot sun, and immediately afterward, I am selected for a random urine drug test. Am I completely safe?
You might not be safe at all. And this specific scenario highlights perhaps the most insidious, hidden biological trap of THC for athletes. To understand why you might fail that test, you have to understand the specific pharmacokinetics of how the human body stores and eliminates THC.
Okay, let's break it down.
Unlike alcohol or water-soluble drugs that are rapidly cleared from the blood by the kidneys, THC is highly lipophilic.
Lipophilic meaning it binds rapidly and tightly to fat molecules.
Yes. When you consume cannabis, the psychoactive delta-9 THC hits your brain, but the resulting metabolites, specifically a non-active metabolite called THC-COH, are rapidly absorbed and sequestered deep inside your adipose tissue, your fat cells.
It gets locked away in the fat.
Exactly. And because it is stored in the fat, it has an incredibly long biological half-life.
Okay, I see the physiological collision course we are setting up here.
If you are an athlete undergoing periods of intense, prolonged cardiovascular exercise, or if you practice intermittent fasting to control your body composition, both of which are incredibly common in elite sports, you trigger a metabolic process called lipolysis.
Lipolysis is the breakdown of stored triglycerides in your fat cells to release free fatty acids into the bloodstream to be burned for mechanical energy.
Yes. When those fat cells break down to fuel your workout, they simultaneously unlock and release the sequestered THC metabolites back into your systemic circulation.
This is genuinely wild. You could be totally sober, you haven't touched the actual substance in a month, but because you went for a really hard fasted morning run and burned a significant amount of body fat, your own metabolism accidentally intoxicates your bloodstream with THC you consumed weeks ago.
Yes. The clinical research definitively demonstrates that plasma THC concentrations can significantly spike during and immediately after fat-burning exercise in individuals who previously used the drug.
Wow.
The THC-COH metabolite floods back into the blood, is eventually filtered by the kidneys, and ends up concentrated in the urine. For an elite athlete navigating the DVOA threshold of 150 nanograms per milliliter, or a commercial pilot subject to strict workplace testing, this represents a massive, uncontrollable biological blind spot.
So you could easily pass a baseline urine test on a Tuesday, execute a massive fat-burning endurance workout on a Wednesday that releases stored metabolites, get randomly tested on a Thursday, and inexplicably fail the drug screen, destroying your career in the process.
It is entirely physiologically possible.
That is an absolutely mind-blowing piece of physiological trivia that carries devastating real-world consequences. We have covered an immense amount of scientific and biological ground in this deep dive. Let's pull all of these complex threads together and synthesize a clear, actionable picture for the listener who is standing in the supplement aisle right now, staring at a bottle of CBD oil, trying to decide whether to throw it in their gym bag or leave it on the shelf.
If we summarize the objective physiological reality derived from the clinical literature, we have to divide the answer into two distinct phases: active performance and systemic recovery.
Let's start with active performance.
Regarding active performance, the data supporting the idea that cannabis, specifically THC, acts as an ergogenic aid to make you a better, faster, or stronger athlete is practically non-existent. In fact, the cardiovascular tax associated with its consumption is a clear, measurable hindrance.
Because of the heart rate.
Right. By upregulating the sympathetic nervous system, it induces tachycardia, it significantly increases your myocardial oxygen demand, and it forces your heart muscle to consume more energy to produce the exact same mechanical output. It is biologically counterproductive for active cardiovascular exertion.
But when we shift our lens away from the cycloergometer in the laboratory and look at the behavioral reality of the locker room, the 2023 survey data from PinZone reveals an undeniable, massive psychological reliance on cannabis for recovery.
Yes. Over 90% of highly active users adamantly swear it helps them bounce back from grueling training blocks.
So what's the takeaway there?
They are utilizing these compounds, primarily CBD, to aggressively mitigate the secondary consequences of training. The peripheral muscle pain of DOMS, the chronic joint inflammation, and the acute hyperarousal of the central nervous system.
And on that specific front, the underlying biological mechanisms of CBD do show genuine therapeutic potential. Its ability to inhibit the enzymatic breakdown of anandamide and its potent anti-inflammatory properties suggest it could be a powerful tool for pain management and, critically, for neuroprotection following concussive impacts.
They do, but we have to remember the dosage problem. Achieving those systemic clinical effects requires massive oral doses that far exceed typical commercial products.
And those high doses introduce the severe risk of liver enzyme monopolization and drug interactions.
Exactly. Ultimately, the unregulated chaos of the supplement market, the ever-present risk of hidden WWADI prohibited trace compounds, and the glaring lack of rigorous long-term data on healthy athletes mean that integrating cannabis into a sports routine right now is a highly experimental, proceed-at-your-own-risk frontier.
It is the absolute Wild West of sports pharmacology. You might stumble upon a botanical goldmine that finally resolves your chronic joint pain and allows you to sleep through the night, or you might inadvertently trigger a massive drug interaction, fail an anti-doping test from fat-released metabolites, and wreck your liver enzymes. The margin for error is incredibly thin, and you have to be meticulously careful.
Before we conclude this deep dive, I actually want to leave you with one final, deeply provocative evolutionary concept to mull over.
Oh, I love these.
It is a biological footnote briefly mentioned in the 2021 Sports Medicine Review, but it elegantly connects everything we have analyzed today regarding human movement and cannabinoid receptors. The authors note a fascinating hypothesis. Exercise itself may have unique endogenous interactions with the endocannabinoid system.
Let's explore the mechanism behind that, because it rewrites a piece of fitness dogma we all grew up with.
For decades, physical education teachers and running magazines told us that the famous runner's high, that profound transient feeling of euphoria, reduced anxiety, and analgesia that washes over you after a long, grueling endurance workout was caused by a flood of endorphins.
Right, everyone talks about endorphins.
But advanced neurobiology has largely debunked the endorphin hypothesis. Endorphins are endogenous morphines. They are relatively large peptide molecules. Because of their molecular size and structure, they cannot easily cross the highly selective blood-brain barrier to bind with receptors in the central nervous system to alter your mood.
So they can't get into the brain to make you feel high.
Exactly. They primarily act in the peripheral body to blunt physical pain. But do you know what distinct class of highly lipophilic molecules crosses the blood-brain barrier with absolute ease?
Endocannabinoids, the body's own native lipid signaling molecules.
Exactly. Modern science now strongly suggests that the psychological euphoria of the runner's high is actually mediated by our body's own naturally produced endocannabinoids like anandamide, flooding the central nervous system in response to the severe metabolic stress of sustained exercise.
Wow.
Evolutionary biologists theorize that this system developed to facilitate persistence hunting in early hominids, rewarding the brain with a potent cocktail of bliss and pain relief to encourage humans to keep running after prey to the point of absolute physical exhaustion.
So, if our biology is perfectly engineered to manufacture and distribute its own custom, perfectly dosed internal cannabis supply simply through the mechanical act of hard, sustained exercise.
Yes. Are external cannabis supplements actually enhancing our recovery and optimizing our biology? Or are we just using a plant compound to artificially hijack a pristine, ancient evolutionary reward system that we were biologically meant to earn through sweat and physical exertion?
That is the ultimate physiological and philosophical question surrounding this entire cultural shift. Wow, are we just synthesizing a chemical shortcut to a feeling of bliss that we are genetically programmed to earn on the track?
It really makes you think about why we take these things in the first place.
That profound evolutionary reality brings us right back to the central tension of modern sports wellness. We constantly seek out the clean, binary, highly engineered solution to our physical limitations. We want a perfectly dosed pill, a specialized tincture, or a beautifully packaged gummy to magically erase the pain of a hard workout and instantly repair the damage.
But the biological waters of human physiology are deep and incredibly complex.
They really are. Your body is a deeply interconnected, beautifully adapted survival machine. And while sports science is slowly, methodically illuminating exactly how these ancient plant compounds interact with our modern metabolic pathways, the absolute best, most perfectly tuned recovery tool you have access to might just be the native chemistry your own brain generates when you force your body to the absolute limit.